Okay, so this is a third part of the video. Again, this is a complicated section. This is probably one of this and the exponential growth section are the two hardest in the course. So it makes sense that it's taking a while to finish this section. So we are on, let's see, problem number 10, it looks like, from the homework, if you're following along. Okay, this is, well, actually, wait a minute. This is, yeah, this is problem number 10. So things look pretty normal here. We would check, if I tried, again, to factor things, we need to know what the zeros are, right? X minus each zero becomes a factor. So to find the zeros, we're going to use the potential rational zeros here. My potential rational zeros are going to be factors of the, factors of the constant term divided by factors of the leading coefficient. Factors of the constant term that is negative 80, so that's going to be plus or minus 1, plus or minus 2, plus or minus 4. What else goes into 80? 5 goes in. This is getting scary. Okay. Plus or minus 6 doesn't go in. 8 goes in, right? 10 goes in. 20 goes in. Oh, no. 40 goes in. 80 goes in. And then the bottom is going to be what? Plus or minus 1, plus or minus 2, because I'm looking at factors of the 4, plus or minus 4. So that means I have to have 1 over 1, 1 over 2, 1 over 4. 2 over 1, 2 over 2, 2 over 4. Blah, 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 blah. Now, some of those will be repeats, and you can eliminate the repeats, but still, it's going to be a ginormous list. How big? Ginormous. Okay? That's a lot. So, I'm going to gamble that maybe there's some whole number zeros in there. How do I find the whole number zeros? Just try plugging in whole numbers and see if you get a 0. Okay, what whole numbers would I plug in? Well, the only whole numbers that would work would be 1 over 1, 2 over 1, 4 over 1, 5 over 1, 8 over 1, 10, 20, 40, and 80 over 1. These are the potential, so these over 1 would be my rational zeros that happen to be whole numbers. Okay? But so I'm just going to go ahead and go to my, quit the table from the previous problem, go to y equals. Let's clear out the function, put in the new function. New function is 4x to the third. Get out of the power. Then plus 27x squared. Let's see, plus 24x minus 80. Okay, now let's go to table set. And I can either leave this on ask and type in my whole numbers. You want to just do that? Leave it on ask. Or just go to second function table set, start it at 0, delta table of 1, and put it on auto. And it's just going to plug in all whole numbers, so including the ones on this list. The ones I'm really interested in are the 1, the 2, the 4, the 5, and the 8, maybe the 10. These are usually too extreme. They usually will not give you a 0. They might in some cases, but most of the time it's going to be one of the smaller guys. All right, so let's go ahead and just do that. Make a table. Okay, do I see any zeros? I'm looking from 0 to 10. I don't see any zeros. Let's go in the negative direction. Ah, there we go. Negative 4 is a 0. Okay, I'm just curious if I see any more. Okay, I'm seeing it doesn't look good there, right? So it looks like the only whole number 0 I'm seeing is negative 4, right here. So, so that's good though. We're happy. Okay, are we happy? We're happy, right? So negative 4 is a 0. So x equals negative 4 is a 0. So that means x take away negative 4 is a factor, which is the same thing as saying x plus 4 is a factor. Okay, so let's go ahead and do a long division and see what's left over. All right, so I'm going to divide x plus 4 into this polynomial, because that's the kind of guy I am. I'm a long division guy. Okay, so x plus 4 divided into 4x cubed plus 27x, x squared plus 24x minus 80 is going to be what? Okay, I have to make the first term on the outside look like the first term on the inside. How do I do that? I'm going to need to multiply this 1 by a 4, and I need to multiply the x by an x squared. Multiply back down. 4x times x is 4x cubed. 4x squared times the 4 is 16x squared. Remember, we're subtracting this because it's been accounted for. And so we end up with, I'm going to end up with 4x cubed. Take away 4x cubed is gone. 27 of these guys, take away 16 of them, gives you 9 of them, right? I'm sorry, 11 of them. So 27 take away 16 is 11x squareds. Okay, and then plus 24x minus 80. So now, how do I make a 1x look like an 11x squared? I need plus 11x. I need the 11 to match the numbers. I need one more power of x to match the x squared. 11x times 1 is 11x. 11x times 4 is 44x. Okay, subtract all that. What do I get? Besides annoyed, ha ha ha, I get what? 11x, oops, that's an x squared, sorry about that. So 11x squared take away 11x squared is gone. 24x take away 44x gives me what? Negative 20x. And then how do I make a 1x look like a negative 20x? I need to multiply by what? Negative 20. Negative 20 times 1 is negative 20, so negative 20x. Negative 20 times 4 is negative 80. Subtract, I can see it's something minus itself. So I end up very happy because I end up with a 0 remainder. Whoops, I'm out of room, but anyways, remainder 0. Okay, so that means I've got my factorization, right? So what's my other factor? So I've got x plus 4 times 4x squared plus 11x minus 20, right? Okay, now how do I factor that? We can try factoring that by hand. So let's give it a shot, see if it works. So I'm going to have, I'll just try this over here. So 4x squared plus 11x minus 20. Let's see if we can factor that by hand. Otherwise, we'll have to use quadratic formula. Let's try, you want to try a 2x and a, to get a 4x squared, you want to try a 2x 2x or 4x 1x? We'll initially try 2x 2x, see if we can get that to work. How do you get a 20? Well, we could try a 4 and a 5, or a 10 and a 2. A 10 and a 2 probably won't work. How about a 4 and a 5? Let's try maybe like plus 5 minus 4. That's going to give me a minus 20, right? But what about the middle? The middle term, outer times outer, would be minus 8x. Nope, that's not going to work. Because that's a pretty big number in the middle, maybe the initial x's should be less balanced than this. Instead of 2x 2x, maybe let's try 4x and x. Now what if you get stuck and you can't figure out the factors? Then you could use quadratic formula on this, although quadratic formula is a real pain in the neck, okay? Anyway, let's just try and do this. So 4x and x, and let's see, we'll try a 5 and a 4 again. So let's try, if I put a plus 5 here, it'll be plus 20 x's, and then the minus 4 here, 20 minus 4 would be 16. What if I put a plus 4 here on the outside, like a plus 4? 4 times 4 is 16, and then I could put a minus 5 here, because I know I need a 4 and a minus 5 to make the minus 20. So if I put a 4 here, I got 16x's minus 5x's does give me 11x. So that's correct. 4x squared plus 16 and minus 5 on the x's gives me 11, and then minus 20. Okay, so that is the factorization. So my final result here is that I had the x plus 4, which we initially found. So I have an x plus 4, and then these two factors, 4x minus 5, and another x plus 4. That's called a repeated root. So we would, when you have two copies of the same root, we usually just use a power 2 on it. Okay, so we would write this. It looks like it's not letting me write down there. We would write this as 4x minus 5, and then x plus 4 to the power 2. Okay, remember from the last module that when you have a repeated root, if you look at the graph, the function's going to hit 0, hit the x-axis at negative 4, but it's going to bounce off and go back the direction it came from, because that's a repeated root. Okay, at 5/4 or 1.25, it'll have another 0. It'll pass through the x-axis, but it's going to pass straight through. Okay, in this case, it would bounce off at negative 4. That's because that's a power 2 root. It'll look like the graph would look like a parabola in the neighborhood of -4. Okay. But anyway, that's a review of the previous module. Now let's go on.